The summer sun hung low over the hedgerows of Normandy on a humid afternoon in July 1944. Somewhere in the tangled maze of ancient earth walls and dense vegetation, a young American sergeant named Curtis Cullen, Jr. sat on the turret of his Sherman tank, staring at a piece of twisted German steel. The metal, scorched and bent from Allied bombardment, had once been part of Hitler's Atlantic Wall, one of thousands of beach obstacles designed to stop the invasion that had come just weeks before. But now, in Cullen's calloused hands, this scrap metal was about to become something entirely different, something that would save thousands of American lives and change the course of the war in Western Europe. The story of how one mechanic's simple innovation transformed the deadliest tanks in the Allied arsenal begins not with glory or grand strategy, but with frustration, mud, and the desperate need to solve a problem that was bleeding the American Army white in the fields of France. The Promise and the Problem. On June 6, 1944, the largest amphibious invasion in human history crashed onto the beaches of Normandy. Operation Overlord, years in the planning, had finally commenced. By the end of that longest day, over 150,000 Allied troops had established a foothold on Hitler's fortress Europe. The world watched and waited to see if this gamble would succeed. In the weeks that followed, the Allied armies pushed inland from their beachheads. The Sherman tank, America's main battle vehicle, rumbled forward by the hundreds. These 30-ton behemoths, with their 75-millimeter main guns and thick armor plating, represented the cutting edge of American industrial might. They were supposed to be the iron fist that would smash through German defenses and race across France toward the German border. But the planners in London and Washington had made a critical miscalculation. They had studied maps, aerial reconnaissance photographs, and intelligence reports. They knew about German positions, artillery emplacements, and troop concentrations. What they had not fully appreciated was the terrain itself. Normandy was bocage country. The term meant little to the American and British soldiers who had trained in the open fields of England or the deserts of North Africa. But to the Norman farmers who had worked this land for 1,000 years, bocage was simply a fact of life. These were not the gentle hedges of an English garden. They were ancient earthen walls, some dating back to Roman times, built up over centuries from stones cleared from fields. Topped with thick, gnarled vegetation, hawthorn, oak, and brambles, so dense they formed an impenetrable barrier, these hedgerows divided the Norman countryside into a patchwork of small fields, each one a natural fortress. The hedgerows averaged 12 feet in height, though some towered to 20 feet or more. Their bases were solid earth and stone, as hard as concrete, sometimes 4 or 5 feet thick. They ran for miles in every direction, creating a maze of narrow lanes and enclosed pastures that turned the gentle French countryside into a defender's paradise. For the German army, retreating after their failure to throw the Allies back into the sea, the bocage was a gift from heaven. Every hedgerow was a ready-made defensive position. Every lane was a prepared ambush site. A handful of German soldiers with a machine gun and some anti-tank weapons could hold an entire American company at bay for hours or even days. But it was the effect on armor that proved most devastating. The Sherman tank, for all its mechanical reliability and ease of production, had a fundamental weakness that would become painfully apparent in the hedgerows of Normandy. When a Sherman attempted to push through or climb over a bocage wall, its front end would rise up, exposing its thin belly armor to enemy fire. For a few terrible seconds, the tank's most vulnerable area would be presented to any German soldier with an anti-tank weapon hiding in the next field over. The German Panzerfaust, a simple disposable anti-tank weapon, could penetrate a Sherman's belly armor with ease. So could the larger Panzerschreck, the German copy of the American bazooka, and the Germans had plenty of both. The results were catastrophic. Tank after tank fell victim to this simple tactic. The Germans would wait until a Sherman began climbing a hedgerow, then fire into its exposed underbelly. The shaped charge would punch through the thin armor and detonate inside the crew compartment. In an instant, 5 men would be gone, and another 30 tons of American steel would become a smoking wreck. Even when the tanks weren't hit, the process of breaching a hedgerow left them vulnerable for precious seconds. The tank would nose up, tracks churning, engine roaring, completely blind to what lay on the other side. By the time the Sherman crested the wall and the driver could see ahead, German defenders had already adjusted their aim. The infantry fared little better. Without armored support, foot soldiers attempting to advance through the hedgerows were cut down by machine gun fire. With armored support, they were exposed during those critical moments when their tanks were vulnerable. It was a tactical nightmare with no apparent solution. American casualties mounted at an alarming rate. What was supposed to be a rapid breakout from the beachhead had turned into a grinding war of attrition, with gains measured in fields rather than miles. Some units were taking casualties as high as those suffered during the initial beach landings. The hedgerows were devouring men and machines alike. Senior officers conferred, engineers were consulted, various solutions were proposed. Some suggested using massive explosive charges to blast through the hedgerows, but this was slow, dangerous, and consumed enormous amounts of ammunition. Others proposed bulldozers, but these were few in number, slow-moving, and vulnerable to enemy fire. Some even suggested going around the hedgerows, but in bocage country there was no around. The hedgerows went on for miles in every direction. The problem seemed insoluble. The advance was stalling, and men were dying. A mechanic named Cullen Curtis Gunn. Cullen Jr. was not supposed to be the man who changed the war. He was a sergeant in the 2nd Armored Division, a tank driver, and mechanic from New Jersey. Before the war, he had worked with his hands, understood machinery, and had a knack for solving practical problems. He was 29 years old, married, and like hundreds of thousands of other young American men, had found himself thrust into a global conflict that would test everything he thought he knew about himself. Cullen was part of a tank crew, and he loved his Sherman. Soldiers often grew attached to their tanks, giving them names, painting them with personal insignia, treating them almost like living things. It made sense. Your tank was your home, your protection, and often the difference between life and ending up as a statistic in some distant headquarters casualty report. But love couldn't solve the hedgerow problem. And as Cullen watched tank after tank in his division fall victim to the bocage, he began to think there had to be a better way. The official Army solution was to tell tank commanders to find gaps in the hedgerows and push through there. But gaps were few and far between, and the Germans knew where they were. They were invariably covered by machine guns, anti-tank guns, or both. Using the gaps was often more dangerous than trying to break through. Some crews tried to push through the hedgerows at full speed, hoping to power through before the Germans could react. This sometimes worked, but just as often the tank would get stuck halfway through, belly exposed, crew trapped, an easy target. Others attempted to dig through at the base. But the ancient stone and compacted earth was incredibly hard, and the work exposed engineers to withering fire from defenders who could see every move from their elevated positions behind the next hedgerow. Cullen watched, listened, and thought. He was a practical man, a mechanic, someone who solved problems by building things. And as he sat in the July heat, watching another disabled Sherman being towed back from the front lines, an idea began to form in his mind. The problem was simple. The Sherman couldn't push through a hedgerow without exposing its belly. So what if, instead of trying to go over the hedgerow, the tank could cut through it? The concept was straightforward, almost elementary. If the tank had something on its front, something strong enough to cut through the roots and earth of the hedgerow base, It could push through at ground level instead of climbing over. No exposed belly, no vulnerable moment, just a clean breakthrough. But what could be strong enough? The hedgerows were incredibly tough. Regular blade attachments wouldn't work. They'd need something specially designed, something that could take the stress of pushing through compressed earth and ancient root systems. Cullen discussed the idea with members of his crew and other tankers in his unit. The response was mixed. Some thought it might work, others were skeptical, but everyone agreed it was worth trying. Anything was better than the current situation. The question was what to build it from. The Army had plenty of steel, but getting official approval for a modification would take weeks or months, time they didn't have. Besides, official channels moved slowly, and men were dying today, not sometime in the distant future, when some committee approved the design. And then Cullen remembered the beaches. When the Allies had landed on D-Day, they had faced thousands of obstacles that the Germans had placed in the surf and on the sand. These were designed to rip the bottoms out of landing craft or block vehicles from advancing. The obstacles came in various designs. Some looked like huge jacks, others like massive angled rails. They were made of heavy steel, designed to withstand waves and explosions. Now, weeks after the invasion, those beaches were clear. The obstacles had been removed, blown up, or simply bypassed. Many had been collected and were sitting in piles near the rear areas, awaiting disposal or recycling. To most people, they were just scrap metal, debris from a battle that had already moved inland. But to Curtis Cullen, they were the solution. Building the beast. The steel from the German beach obstacles was perfect for Cullen's purposes. It was heavy, incredibly strong, and already cut into manageable pieces by Allied demolition teams. It was also readily available, and best of all, free. No requisition forms, no waiting for approval, no questions asked. It was scrap metal that anyone could take. Cullen requisitioned a welding kit and got to work. He wasn't working from any blueprint or engineering diagram. This was pure practical problem-solving, the kind of work he'd done his whole life. He sketched rough designs in the dirt, discussed angles and placement with other mechanically minded soldiers, and then started cutting and welding. The design that emerged was deceptively simple. It consisted of several sharp steel prongs cut from the beach obstacles, welded to a sturdy frame that could be attached to the front of a Sherman tank. The prongs angled downward and forward like enormous tusks, or the blades of a plow. When the tank moved forward, these prongs would dig into the base of a hedgerow and cut through the earth and roots, allowing the tank to push through at ground level. The first prototype was crude, but functional. Cullen welded it together himself, working through long hours in the summer heat. Other soldiers gathered to watch, offering suggestions, lending a hand. Word of what he was doing spread through the division. Officers came to look. Some were encouraging, others were doubtful. The question everyone asked was simple: would it work? There was only one way to find out. A suitable test site was selected, a hedgerow far enough from the front lines to be safe, but typical enough to be representative. Cullen's Sherman, now sporting its strange new attachment on the front, was driven into position. A small crowd gathered to watch. Success would mean a solution to one of the biggest tactical problems facing the Allied advance. Failure would mean back to square one. Cullen climbed into the driver's seat. His commander gave the order. The engine roared to life, and the 30-ton Sherman lurched forward. The steel prongs bit into the base of the hedgerow. For a moment, there was resistance. The tank's tracks churned, throwing up clods of earth. The engine labored. Then, with a sound like tearing fabric amplified 1,000 times, the prongs cut through. The Sherman pushed forward, and the hedgerow simply parted. The tank stayed level, belly armor protected, moving through in a matter of seconds. On the other side, Cullen stopped the tank and looked back. Where solid hedgerow had stood moments before, there was now a clean breach. The prongs had cut through the earthen base, like a hot knife through butter. The tank had gone through fast, level, and completely protected. It worked. The watching soldiers erupted in cheers. Officers who had been skeptical rushed forward to examine the device. Within hours, word had reached division headquarters. Within a day, it had reached Corps Command. Cullen's invention, which would come to be known as the Cullen hedgerow cutter, or more commonly as rhino teeth or tusks, had just changed the war. From one to many, the reaction from higher command was immediate and enthusiastic. Here finally was a solution to the hedgerow problem that was simple, effective, and could be implemented immediately. No waiting for factory production, no shipping delays, no lengthy testing programs. The materials were already in France, sitting in piles on the beaches. The modification could be done by unit mechanics in the field, and most importantly, it worked. General Omar Bradley, commander of the 1st United States Army, immediately ordered that every available Sherman be equipped with the device. The race was on. Supply officers were dispatched to the beaches to collect every piece of German obstacle steel they could find. Welding equipment was distributed to field workshops. Mechanics who had never done this kind of work before were given crash courses in fabrication. The entire operation moved with an urgency that only combat can create. Within days, the first production run of Cullen cutters had been completed. Within a week, hundreds of Shermans were sporting the distinctive steel prongs. Within 2 weeks, the modification was being installed on nearly every Allied tank in Normandy. The transformation in tactical capability was immediate and dramatic. Tanks that had previously been forced to seek gaps or risk climbing over hedgerows could now simply push through wherever they wanted. The element of surprise returned to Allied operations. German defenders, used to knowing exactly where American armor could and couldn't go, suddenly found tanks appearing in unexpected places. Infantry advancing behind the modified Shermans found their job immeasurably easier. The tanks could now lead the way, breaking through hedgerows and providing covering fire without that vulnerable moment of exposure. Casualties dropped. Morale soared. The Germans, caught completely off guard by this simple innovation, struggled to adapt. Their defensive tactics, so effective for the previous weeks, suddenly became far less potent. The bocage, which had been their greatest advantage, was being neutralized by pieces of their own beach obstacles. But perhaps the most remarkable aspect of the Cullen cutter was its simplicity. This was not some high-tech wonder weapon designed in a laboratory. It was a practical solution to a practical problem created by a regular soldier using salvaged materials. It required no special training to use. Any Sherman driver could operate a tank with the device. Any mechanic could install one. It was the democratization of innovation in its purest form. Other soldiers, inspired by Cullen's example, began making their own modifications and improvements. Some created variations with different prong configurations. Others experimented with different attachment methods. The basic design remained the same, but small refinements appeared as different units adapted the concept to their specific needs. This grassroots innovation spread beyond just tanks. Engineers began using similar cutting devices on bulldozers. Some units experimented with portable versions that could be pushed by infantry. The principle of using sharp steel prongs to cut through hedgerows at the base became standard Allied doctrine in the bocage. The impact on operations was profound. In late July 1944, the Allies launched Operation Cobra, the breakout from Normandy. This massive offensive, involving thousands of troops and vehicles, relied heavily on the ability of armored units to push through the bocage country rapidly. Without the Cullen cutter, Cobra would have been impossible. With it, the operation succeeded beyond expectations. American and British forces smashed through German defenses, finally breaking free of the hedgerow maze that had contained them for weeks. The breakthrough led directly to the liberation of Paris in August and the rapid Allied advance toward Germany in the fall. Historians would later debate how much longer the bocage fighting would have lasted without Cullen's innovation. Some suggested weeks, others months. The German army, already stretched thin and facing Soviet advances in the east, might have been able to hold Normandy indefinitely if the Allies had been unable to solve the hedgerow problem. But they had solved it thanks to one sergeant with a welding torch and a pile of scrap metal. Recognition and legacy. Curtis Cullen's invention did not go unrecognized. In a ceremony held in France, he was awarded the Legion of Merit, one of the highest decorations the United States military can bestow. The citation praised his initiative, ingenuity, and the significant tactical advantage his invention had provided to Allied forces. But Cullen himself remained modest about his achievement. In interviews conducted after the war, he consistently downplayed his role, insisting that many soldiers had worked on the problem and that he had simply been the one to come up with a workable solution. He credited his fellow tankers, the mechanics who had helped fabricate the first prototypes, and the officers who had supported testing and implementation. This humility was characteristic of Cullen and of many men of his generation. They had done what needed to be done, solved the problems in front of them, and then moved on to the next challenge. The war was bigger than any one person, and everyone had their part to play. After the war, Cullen returned to the United States and resumed his civilian life. He avoided publicity, rarely spoke about his wartime experiences, and lived quietly until his passing in 1993. To the end of his life, he maintained that he had simply been doing his job, but the legacy of his invention lived on. The Cullen cutter became a standard piece of equipment in military history books, featured in documentaries and museums. Original examples were preserved and put on display. The modified Shermans with their distinctive prongs became iconic images of the Normandy campaign. More importantly, Cullen's story became a lesson in the value of practical innovation. Military academies began teaching it as an example of how simple solutions to complex problems can emerge from unexpected sources. Engineers studied it as a case study in field modifications and rapid prototyping. Historians cited it as evidence that wars are won not just by grand strategy, but by individual initiative at all levels. The Cullen cutter also had implications beyond World War II. It demonstrated that soldiers in the field, those actually facing the problems, often have the best perspective on how to solve them. This lesson would influence military procurement and development in the decades that followed, leading to more emphasis on feedback from frontline troops and faster implementation of field modifications. In many ways, the story of Curtis Cullen and his hedgerow cutter represents the American approach to warfare in the 20th century, practical, innovative, and focused on solving immediate problems with available resources. It stands in stark contrast to the rigid top-down military doctrines that had dominated European warfare for centuries. The broader context. To fully appreciate the significance of Cullen's invention, it's important to understand the broader context of the Normandy campaign and the challenges facing Allied forces in the summer of 1944. The decision to invade Normandy had been years in the making. Stalin had been demanding a second front in Europe since 1942, arguing that the Soviet Union was bearing the brunt of fighting against the Third Reich. Churchill and Roosevelt had agreed in principle, but knew that a premature invasion would be catastrophic. The failed Dieppe raid of 1942 had demonstrated the perils of attempting an amphibious assault without adequate preparation. By 1944, the Allies were ready. They had built up massive forces in Britain, trained extensively, and developed specialized equipment for the landing. The invasion, when it came, succeeded in establishing a beachhead, but that was only the first step. The real test would be the advance inland. The bocage country of Normandy represented a challenge that Allied planners had understood in theory, but had not fully appreciated in practice. Aerial reconnaissance could photograph the hedgerows, but couldn't convey their density or the tactical problems they created. No amount of training in England or Africa could fully prepare soldiers for the reality of bocage fighting. The Germans, by contrast, had weeks to prepare their defenses after D-Day. They knew the terrain intimately and had developed tactics specifically designed to exploit it. Elite SS Panzer divisions, paratroop units, and regular Army formations all contributed to a defensive network that turned every field into a potential fortress. American forces, despite their material advantages, found themselves fighting at a severe tactical disadvantage. The Sherman tank, which had performed well in North Africa and Italy, seemed inadequate for the bocage. Soldiers trained in mobile warfare found themselves engaged in static, grinding combat reminiscent of the Western Front in World War I. Casualties mounted. Some units lost more men in the first weeks in Normandy than they had during the entire Italian campaign. Officers began to worry that the offensive might stall completely, giving the Germans time to reinforce and potentially counterattack. It was in this context that Colin's invention arrived like a bolt from the blue. The speed with which it was adopted and implemented speaks to the desperate need for any tactical advantage. The fact that it came from a sergeant, rather than an engineering corps or a research laboratory, was almost irrelevant. What mattered was that it worked. The Cullen cutter allowed the Allies to regain the initiative. Combined with overwhelming air superiority and growing numerical advantages as more troops landed, it tipped the balance decisively in favor of the attackers. The breakout from Normandy, when it came, was swift and devastating to German forces. Technical aspects and variations. While the basic principle of the Cullen cutter remained constant, various technical adaptations appeared as different units experimented with the design. Understanding these variations provides insight into how the innovation evolved in the field. The original Cullen design featured 4 or 5 prongs made from sections of German beach obstacles. These prongs were typically 18 to 24 inches long, angled downward at approximately 30 degrees, and spaced evenly across the front of the tank. The prongs were welded to a sturdy frame, which was in turn attached to the tank's front armor using existing mounting points. The genius of the design lay in its simplicity. The prongs acted like enormous chisels, concentrating the tank's forward momentum into narrow cutting edges. As the tank advanced, these edges would slice through the compacted earth and roots at the base of the hedgerow. The angle design meant that debris was pushed down and to the sides, preventing it from accumulating in front of the tank and slowing progress. Some units experimented with different prong configurations. The British, who also adopted the device, sometimes used 6 prongs in a more evenly distributed pattern. American heavy tank units occasionally created more robust versions for their heavier M26 Pershing tanks, though these saw limited use in Normandy. The attachment method also evolved. Early versions were simply welded directly to the tank's front armor. Later versions used bolt-on frames that could be removed or replaced more easily. This allowed tanks to remove the device when not operating in bocage country, reducing weight and improving mobility on open terrain. One interesting variation was the development of sharpened tips on the prongs. Some mechanics discovered that putting a beveled edge on the end of each prong improved cutting efficiency. This modification spread quickly, with workshops setting up production lines to process prongs with these sharpened tips. The weight of the device was significant but manageable. A full Cullen cutter assembly typically weighed between 500 and 700 pounds, depending on the configuration. This was substantial, but represented less than 2% of the Sherman's total weight, so it had minimal impact on performance. Durability proved excellent. The heavy steel of the German beach obstacles was incredibly tough, and the prongs rarely broke or bent, even after repeatedly smashing through hedgerows. Some tanks operated for weeks with the same Cullen cutter, only requiring replacement when damage from enemy fire rendered the device ineffective. Maintenance was minimal. The prongs occasionally needed to be straightened if they bent slightly, and welding points sometimes required reinforcement, but overall, the device was remarkably robust. This low-maintenance requirement was crucial in combat conditions where time and resources for repairs were always limited. The device did have some limitations. It added length to the tank, making it slightly more difficult to maneuver in tight spaces. The prongs could occasionally get caught on underground obstacles like large rocks or tree roots, requiring the tank to back up and try a different approach. And in very dense hedgerows with particularly thick root systems, the cutting process could take longer than ideal, potentially exposing the tank to enemy fire. But these were minor issues compared to the alternative of trying to climb over hedgerows and exposing the tank's vulnerable belly armor. Soldiers quickly learned to work around the limitations and exploit the advantages. The human element behind every piece of military hardware, behind every tactical innovation, there are human stories. The Cullen Cutter is no exception. The device was created by men, installed by men, and used by men who were far from home, fighting in a war that many of them didn't fully understand but knew had to be won. Consider the tank crews who first used the Cullen Cutter in combat. These were young men, most in their late teens or early 20s, operating complex machines in lethal conditions. Inside a Sherman tank, the world was reduced to cramped spaces, limited visibility, deafening noise, and the constant awareness that enemy fire could penetrate the armor at any moment. Before the Cullen Cutter, attacking a hedgerow was a moment of maximum vulnerability. The driver would approach the wall, often unable to see what was on the other side. The commander standing in the turret would be exposed to small arms fire. The gunner would be blind as the tank tilted upward. The loader and assistant driver could only wait and hope. For those few seconds when the tank was climbing over the hedgerow, the crew was helpless. Many tank crews had lost friends to this procedure. They had seen other Shermans brew up, as the soldiers grimly called it, when a Panzerfaust or anti-tank round penetrated the thin belly armor. They had watched crews scramble to escape burning tanks, some making it, others not. Every approach to a hedgerow was a roll of the dice. The Cullen Cutter changed that psychological equation. Suddenly, breaching a hedgerow was no longer a moment of terror but a routine operation. The tank stayed level, armor properly oriented, crew protected. The difference in confidence and morale was incalculable. Infantry soldiers also benefited immensely. They had been taught to advance behind tanks, using the armor as mobile cover. But when tanks had to climb hedgerows, the infantry was forced to either wait exposed or advance without armored support. Neither option was appealing. With the Cullen Cutter, tanks could lead the way through hedgerows, and infantry could follow closely behind, moving from field to field with far less exposure to enemy fire. The mechanics who installed the devices also have their stories. These men worked long hours in field workshops, often within range of enemy artillery. They fabricated, welded, fitted, and tested the Cullen Cutters, knowing that their work would directly impact the survival of their fellow soldiers. The pressure to get it right, to make sure every weld was solid and every prong properly angled, was immense. There were also the supply personnel who scoured the beaches for suitable scrap metal. They loaded tons of steel onto trucks, transported it to forward areas, and distributed it to the various units. It was unglamorous work, but essential. And finally, there were the officers who had to make the decision to adopt and implement the device. This might seem like an obvious choice in retrospect, but at the time it represented a significant commitment of resources and effort, based on an unproven design from an unofficial source. Some officers embraced the innovation immediately, others were more cautious. But ultimately the evidence of its effectiveness convinced even the skeptics. All of these people, from the general staff to the individual soldier in the field, were part of the story of the Cullen Cutter. It was a collective effort, demonstrating what can be achieved when necessity drives innovation and bureaucracy takes a backseat to practical solutions. Impact on German forces. The introduction of the Colon cutter also had a profound psychological impact on German forces defending Normandy. For weeks, they had been fighting with the confidence that came from superior defensive terrain. The bocage gave them a massive advantage, allowing relatively small numbers of soldiers to hold off much larger Allied forces. German soldiers had developed effective tactics for dealing with Allied armor. They knew that Sherman tanks would try to push through or climb over hedgerows, and they positioned their anti-tank weapons accordingly. The procedure was almost routine. Wait for the tank to expose itself, aim for the belly armor. Fire. The results were often devastating. But suddenly, seemingly overnight, the rules changed. Shermans began appearing through hedgerows without warning, staying level, protected by their frontal armor. The carefully prepared ambush positions were no longer as effective. The psychological advantage began to shift. German after-action reports from this period show confusion and concern about the new Allied capability. Officers reported that tanks were breaking through hedgerows in unexpected places, making defensive planning much more difficult. Some reports even suggested that the Americans had developed a new type of tank specifically designed for bocage fighting. The reality, of course, was much simpler. It was the same Sherman tanks, just with a field modification made from scrap metal. But to the Germans on the receiving end, the effect was the same. The bocage was no longer the impenetrable fortress it had been. This had broader implications for German strategy in Normandy. The High Command had been counting on the bocage to slow the Allied advance long enough for reinforcements to arrive from other parts of France and Germany. When that didn't happen, when Allied forces began breaking out in late July, the entire German defensive position in France became untenable. Some historians argue that the Colon cutter, along with Allied air superiority and numerical advantages, made the defeat of German forces in France inevitable. Others suggest that without this innovation, the bocage fighting could have lasted much longer, potentially allowing Germany to stabilize the Western Front. What's certain is that the device had an impact far beyond its simple mechanical function. It affected tactics, strategy, and the psychology of both sides in the conflict. Lessons for military innovation. The story of the Colon cutter offers several important lessons about military innovation that remain relevant today. First, it demonstrates the value of listening to soldiers in the field. Colon was not a professional engineer or a weapons designer. He was a mechanic and tank driver who understood the problem because he faced it every day. His perspective, gained from direct experience, led to a solution that eluded more formally educated engineers. Second, it shows the importance of rapid prototyping and field testing. Colon didn't spend months developing detailed plans or conducting extensive studies. He built a prototype, tested it, and refined the design based on results. This iterative approach, now common in modern engineering, was relatively unusual in the rigid military hierarchy of World War II. Third, the story illustrates how simple solutions are often the best. The Colon cutter was not a technological marvel. It was just sharpened steel prongs welded to a tank, but it solved the problem completely and could be implemented immediately with available materials. More complex solutions might have been more elegant, but they wouldn't have arrived in time to make a difference. Fourth, it demonstrates the importance of flexible, adaptive command structures. The fact that Colon's innovation was adopted so quickly, spreading from one tank to thousands in a matter of weeks, shows that the American military in World War II was capable of rapid adaptation when circumstances demanded it. Not all military organizations have this flexibility. Finally, the story shows how wars are won not just by grand strategy, but by countless small innovations and improvements at all levels. The Colon cutter didn't win World War II by itself, but it was one of thousands of tactical and technical advantages that collectively gave the Allies the edge they needed. Modern militaries study the Cutter story as part of their doctrine on innovation and adaptation. The lesson is clear: create an environment where soldiers feel empowered to identify problems and propose solutions, provide the resources and authority to test new ideas quickly, and be willing to implement good solutions rapidly regardless of their source. The Normandy Breakout. By late July 1944, the Allies were ready to capitalize on their new advantage. Operation Cobra, the breakout from Normandy, was planned as a massive armored thrust that would shatter German defenses and allow mobile warfare to resume. The operation depended heavily on the ability of armored units to move quickly through Bocage country. On July 25th, the operation began with a massive aerial bombardment. Thousands of American bombers dropped high explosives on German positions, pulverizing defensive lines. Unfortunately, some bombs fell short, causing casualties among American troops, but the damage to German forces was severe. Then the tanks rolled forward. Sherman after Sherman, many equipped with cutters, pushed through the hedgerows. The Germans, already reeling from the bombardment, found themselves unable to establish effective defensive lines. Every time they tried to set up a position, American armor would crash through an unexpected hedgerow and flank them. The advance gained momentum. What had been measured in yards per day in June was now miles per day. By the end of July, American forces had broken through the German defensive belt entirely. The race for Paris was on. British and Canadian forces in the eastern sector also benefited from the Cutter, though they faced somewhat different terrain. The combination of improved tank capabilities and air superiority gave the Allies an overwhelming advantage. German forces, unable to contain the breakthrough, began a fighting retreat. Some units maintained good order and conducted effective rearguard actions. Others disintegrated under the pressure. The German Seventh Army, which had borne the brunt of the fighting in Normandy, was essentially destroyed. By mid-August, Allied forces were racing across France. The liberation of Paris on August 25th was the culmination of the breakout that had begun with Operation Cobra, and while many factors contributed to this success, the ability of Allied armor to move freely through the Norman bocage, thanks in large part to Curtis Cullen's innovation, was crucial. Comparing to other innovations, the Cutter was not the only field innovation of World War II, but it was among the most successful. Comparing it to other wartime adaptations provides useful context for understanding its significance. The British, for example, developed a remarkable array of specialized armored vehicles for the D-Day landings. These included flail tanks for clearing mines, bridge-laying tanks, and flame-throwing tanks. These specialized vehicles, collectively known as Hobart's Funnies, after their developer, Major General Percy Hobart, were ingenious solutions to specific problems. However, they were complex, purpose-built machines that required specialized training and maintenance. The Cutter, by contrast, was a simple modification that any tank could receive and any driver could use. Its simplicity was its strength. The Germans also developed numerous field modifications during the war. German tank crews became expert at improvising additional armor, often welding spare track links or metal plates to their vehicles for extra protection. These modifications were effective, but were responses to inferior armor rather than tactical innovations. The Soviet Army, fighting on the Eastern Front, developed the practice of mounting infantry on the outside of tanks, allowing them to ride into battle and dismount quickly for assault. This was an effective tactic but came at a high cost in casualties. It was an innovation born of desperation rather than engineering insight. What made the Cutter exceptional was its combination of simplicity, effectiveness, and ease of implementation. It solved a specific tactical problem completely, could be produced with available materials, and required no special training. This combination of factors made it one of the most successful field innovations of the war. The psychological dimension beyond its tactical applications, the Cullen cutter had significant psychological effects on both Allied and German forces. For Allied soldiers, the device represented something more than just improved tactics. It was proof that their army was adaptive, innovative, and responsive to problems identified by frontline troops. This had an important effect on morale. Soldiers who had felt trapped and vulnerable in the bocage suddenly had a tool that gave them a fighting chance. The knowledge that someone had listened to their problems and come up with a solution created a sense of trust in the command structure and confidence in their equipment. For the Germans, the appearance of the Cullen cutter was demoralizing. They had believed that the bocage would provide them with a significant defensive advantage, allowing them to hold off the Allies for months. When that advantage was neutralized by such a simple innovation, it was a blow to their confidence. German soldiers began to realize that they were facing an enemy with seemingly unlimited resources and remarkable adaptability. No matter what advantage the Germans tried to exploit, the Americans found a way to neutralize it. This psychological pressure contributed to the erosion of German morale and fighting effectiveness, recognition, and remembrance. Curtis Cullen's contribution to the war effort was recognized not only during the conflict, but in the decades that followed. Museums dedicated to World War II, including the National World War II Museum in New Orleans, feature displays about the Cullen cutter. Preserved Sherman tanks equipped with the device are on display at various military museums around the world. In Normandy itself, where the device proved its worth, there are several memorials and educational displays that explain its significance. Tour guides regularly tell the story of the sergeant who changed the war with scrap metal and a welding torch. It has become part of the larger narrative of the Normandy campaign. Cullen himself received numerous honors after the war, though he consistently deflected credit. In interviews, he emphasized that many people had contributed to the development and implementation of the device. This modesty was characteristic of many veterans of his generation who saw their actions as simply doing their duty rather than anything exceptional. But historians and military analysts have ensured that his contribution is not forgotten. Books about the Normandy campaign routinely include sections on the hedgerow problem and its solution. Academic papers analyze the innovation from various perspectives: engineering, tactics, military history, and organizational behavior. The story has also entered popular culture. It appears in documentaries, is referenced in films about World War II, and is a favorite among military history enthusiasts. The image of a Sherman tank with steel prongs mounted on its front has become iconic. Broader implications. The success of the Cullen cutter had implications that extended far beyond World War II. It influenced military thinking about innovation, procurement, and the relationship between frontline troops and command structures. During the Cold War, both American and Soviet military planners studied the lesson of the Cullen cutter. How could they ensure that their forces would be similarly adaptive in future conflicts? How could they create systems that encouraged innovation from below while maintaining necessary command and control? The American military, in particular, embraced the concept of empowering junior officers and enlisted personnel to identify problems and propose solutions. This became part of the broader philosophy of mission command, where subordinates are given objectives and the freedom to determine how to achieve them. The story also influenced procurement processes. Military planners began to recognize that not every problem could be anticipated in advance, and that rigid centralized development of equipment might miss important needs. This led to more emphasis on rapid prototyping, field testing, and quick implementation of successful modifications. In the civilian world, the Cullen cutter story became a case study in innovation and problem solving. Business schools and engineering programs use it to illustrate principles of user-centered design, rapid prototyping, and the importance of listening to people on the front lines of any operation. The final advance. With the bocage problem solved and the breakout from Normandy accomplished, Allied forces raced across France in late summer and fall of 1944. The Colon cutter, having served its crucial purpose in the hedgerows, remained on many tanks as they advanced, though it saw less use in more open terrain. Some units removed the devices to save weight and improve maneuverability. Others kept them attached, reasoning that they might encounter similar obstacles later. As it turned out, some tank crews did find the device useful in other situations, using the prongs to push through obstacles, or even as improvised battering rams against fortified buildings. But the Colon cutter's greatest service had been rendered in the fields of Normandy. It had helped break the deadlock that threatened to bog down the entire campaign. It had saved countless lives by protecting tanks during breaching operations, and it had demonstrated the power of simple, practical innovation in the face of complex problems. By the time Allied forces reached the German border in the fall of 1944, the character of the fighting had changed again. The mobile warfare that characterized the race across France gave way to more static combat as the Germans fell back on prepared defensive positions. The bocage was far behind, a memory of a particularly difficult phase of the campaign, but for those who had fought there, who had seen friends lost to the terrible vulnerability of attacking hedgerows, the Colon cutter remained a powerful symbol. It represented not just a tactical innovation, but hope, adaptability, and the triumph of practical problem-solving over rigid doctrine. Legacy in military doctrine. The Colon cutter occupies an important place in military doctrine and training. It is taught at military academies as an example of successful field innovation. Officer candidates study it to understand how to encourage and implement new ideas from subordinates. Engineers examine it as a case study in rapid problem-solving with limited resources. The device also appears in broader discussions about military adaptation. How do armies learn during wartime? How quickly can they identify problems, develop solutions, and implement changes? The Colon cutter story provides a nearly perfect example of rapid adaptation under pressure. Modern militaries face different challenges than those of World War II, but the principles remain relevant. Whether fighting in urban environments, desert terrain, or jungle, forces encounter unexpected obstacles and must adapt quickly. The lesson of the Colon cutter, that simple solutions from frontline troops can be as valuable as complex systems from research laboratories, continues to resonate. Some military thinkers argue that modern procurement processes have become too complex and risk-averse, making it harder to achieve the kind of rapid adaptation that the Colon cutter represented. They point to the device as an example of what can be accomplished when bureaucracy is set aside in favor of practical problem-solving. Others argue that modern warfare's technical complexity makes the Colon cutter model less applicable. Today's weapon systems require sophisticated engineering, extensive testing, and careful integration. A mechanic with a welding torch cannot simply modify a modern main battle tank the way Colon modified his Sherman. But even these skeptics acknowledge the value of the underlying principle. Listen to the people facing the problems, encourage creative thinking, and be willing to test and implement good ideas regardless of their source. These lessons transcend any particular era or technology. The human cost. While celebrating the success of the Colon cutter, it's important to remember the human cost that made such innovation necessary. The hedgerows of Normandy claimed thousands of American, British, Canadian, and German lives. Every field became a battlefield, every stone wall a potential grave marker. The men who fought there experienced combat of a particularly grinding, claustrophobic nature. Visibility was limited. Artillery and mortar fire could arrive without warning. Snipers lurked behind every hedgerow. The wounded often could not be evacuated quickly, making injury particularly terrifying. Tank crews faced the additional horror of burning vehicles. A Sherman hit by anti-tank fire would often catch fire, and the crew had only seconds to escape. Many didn't make it. The survivors carried the memories of lost friends for the rest of their lives. The Cullen cutter reduced these casualties, but it could not eliminate them. The device protected against one specific vulnerability, but could not make tanks invulnerable. Combat remained deadly even with the innovation. And for the German soldiers defending Normandy, the summer of 1944 was a nightmare. Outnumbered, outgunned, and under constant air attack, they held their positions with remarkable tenacity. Many were conscripts, some were teenagers, others were veterans of the Eastern Front transferred west. They fought and died in the Norman fields, often without any clear understanding of why they were fighting or what they were fighting for. War has no real winners, only survivors. The Cullen cutter helped some men survive who otherwise would not have. That is its greatest achievement and its most important legacy. Conclusion: the power of simple solutions. The story of Curtis Cullen and his hedgerow cutter is more than just a military anecdote. It is a profound lesson about innovation, adaptation, and the value of practical problem solving. In an era of increasingly complex technology and sophisticated systems, the Cullen cutter reminds us that sometimes the best solution is also the simplest. Cullen did not have access to research laboratories, computer simulations, or extensive testing facilities. He had a problem, some scrap metal, a welding torch, and the determination to find a solution. What he created changed the course of a campaign and influenced military thinking for generations. The device itself was eventually rendered obsolete. Modern tanks face different challenges than Sherman tanks in the hedgerows of Normandy. But the principle behind it, the idea that good solutions can come from unexpected sources and that simplicity often beats complexity, remains timeless. Today, when faced with seemingly intractable problems, it's worth remembering the mechanic from New Jersey who looked at a pile of German beach obstacles and saw not scrap metal, but a solution. Sometimes the answer is right in front of us, waiting to be recognized by someone with the insight and determination to act. Curtis Cullen's contribution to the Allied victory in World War II cannot be quantified precisely. We cannot say exactly how many lives his invention saved or how much faster it made the advance through France. What we can say is that it mattered, that it made a difference at a crucial moment, and that it stands as an enduring example of American ingenuity and adaptability. In the end, the Cullen hedgerow cutter was more than just a tactical innovation. It was a testament to human creativity in the face of adversity. It proved that one person with determination and a good idea really can change the world, or at least change a war. And in the summer of 1944, in the fields of Normandy, that was more than enough. The prongs of steel that tore through ancient hedgerows also tore through the assumption that innovation must come from above, that complex problems require complex solutions, and that individual soldiers are merely cogs in a vast military machine. Curtis Cullen showed that sometimes one mechanic with a welding torch can accomplish what entire research divisions cannot. That lesson, forged in the crucible of combat and proven in the fields of France, remains as relevant today as it was 8 decades ago. And that ultimately is the true legacy of the man who made Sherman tanks immune to the ancient barriers of Normandy with nothing more than scrap metal and ingenuity.